My name is Benjamin Reed, and I have the greatest job maybe in the world. I get to lead a group of individuals in the Satellite Servicing Projects Division. So what is that? It's a series of projects that are all centered about satellite servicing, being able to work on, upgrade, improve, repair, relocate, assemble satellites in space, which is all pretty novel if you're thinking about servicing without the aid of the space shuttle. And so I am the Deputy Division Director of SSP.
So what is sort of the genesis behind the idea of servicing satellites? Because what I heard in your previous talk is that they are not designed to be serviced.
They are not, but they're valuable. So that's the point. The cost, they are extremely valuable. Cost is all over the place based on who built them for what purpose. They are not immune to degradation, mistakes, anomalies, becoming obsolete because technology on the ground has advanced, becoming obsolete because the need for them has changed, the user base has changed. So there is a tremendous need. There is also the need stemming from the fact that to get into space, well, it's obvious to say, but it bears saying out loud, to get into space, one has to ride atop a rocket. And riding on rockets is expensive. Rockets are not cheap. And it's also difficult to build a precision instrument that first is going to be shaken to death. And as a result, we, the global aerospace community, have to build our things to be able to withstand the launch environment. So if one could put together a satellite in space that didn't have to be together on the rocket, it opens up new possibilities. For example, James Webb Space Telescope, many viewers will probably be familiar with what it looks like with the segmented mirrors. So those segmented mirrors are attached to a backplane holding them, and that's got to be able to withstand launch loads and then be extremely precise in their location and the right figure and pointing tip tilt the right direction to get a coherent image on the detector. Imagine launching them as dinner plates stacked in an egg carton, nice and protected. You get into space with a gossamer, thin, delicate structure, and then they are placed into their position. You can servicing would enable this, and it would allow missions to take place that otherwise wouldn't because of the confines of payload volume and the vibrations in launch. So servicing or assembly is, one would say, perhaps the killer app for servicing capability. It enables that which otherwise cannot be accomplished.
So what about the satellites that are already up there now that we talked about running out of fuel?
So
you have to restore an mission.
Yeah, so there is neighborhood of about 450 operational satellites in just geosynchronous orbit alone. The satellites are several hundred million each, give or take. The government satellites maybe closer to a billion. Commercial closer to 200, 250, 300 million without launch vehicle. 15 of these geosynchronous satellites are replaced every year on average due to lack of fuel. So there's another need, there's another user community that could benefit from relocation and or refueling. So you have a satellite that was not designed with refueling in mind, yet it's a candidate to be refueled with the fleet owner, whether that's a commercial company or a government, wants to keep that satellite services from that satellite going longer. Let's extend its life rather than having to build a new one. So that drives the need for refueling. The complexity comes in the details. How do you find that satellite as it's whizzing around in the gigantic vastness and blackness of space? How do you safely rendezvous with it without the risk of colliding with it? Once you rendezvous with it, how do you gently capture it, grasp it, right? You don't want to crush the egg when you pick it up out of the carton. You don't want it to fall out of your hand. So we as humans are really good at finding that Goldilocks grip. Pick up a toddler. You want the Goldilocks grip. You don't want to crush their arm. You also don't want them to slip out of your arms and fall on the floor. Humans are incredibly sophisticated, without even thinking of it, at that Goldilocks grip based on whatever the object is. And now we have to be able to program an autonomous robotic system with the Goldilocks grip of that client. Gentle, but firm enough that they don't slip out. As the two are racing around in geo at 8,000 miles an hour, and low Earth orbit, maybe 16,000 miles an hour. Pretty decent velocity. So, we found it, rendezvous with it, we gently grasped it. Now we need to undo the wrapping paper that satellites are wrapped in. You can see a lot of wrapping paper on that client. So here's a full-scale mock-up of what a satellite looks like in orbit. Not a lot of handles to grab, and not a lot of places where one that isn't covered with blanket or an antenna. So we need to get through the blanket to get to the fueling valve. That's going to require dexterous manipulation via robotics, humans on the ground controlling it, to cut blanket, peel back blanket, then hold it back, cut wires, remove caps, and there's the valve. So many, many steps just to expose the fuel valve. Where in a car, that involves flap, untwist the cap, right? What takes maybe 5 seconds or less with a car will take us, 3.5, 4 days of intensive robotic operations by highly skilled robotics operators right here in this laboratory, just to get access to the valve. Another difference with a car is that a car's fuel system is not under pressure. Maybe a little. You might hear a slight pressure release when you unscrew a gas cap to an automobile, but it's not 250 psi, which is a typical pressure for an on-orbit satellite. For reference, a car tire is maybe 30 to 50 psi. The fuel system in satellites in orbit is more like 250 psi. So we need to be able to attach a fueling robotic tool remotely from the ground with such a nice tight seal that we're not going to leak it under the pressure. So once we make this nice tight seal, we're then going to open the valve robotically from the ground and then push in against 250 psi pressure head an additional, say, 100 kilograms of explosive satellite fuel. And it is explosive by design, which is why we use explosive gasoline in our cars so that it explodes nicely in our pistons. We want the propellant inside a satellite to explode when we ask it to in a particular location, not at random, to cause something to translate, cause the satellite to translate or turn in space. So that's some of the complexities that is inherent with fueling a satellite not designed to be serviced that we don't think about with cars, because cars are designed to be very little training to become an experienced automotive refueling technician. Not the case with satellites.
So what is the status of Restore L? How far along are you with that program?
The Restore L mission is in formulation. NASA has a well-established technique or procedure for concept, to formulation, to execution or implementation, to launch, and then mission ops. So we're in the formulation phase. So we are refining designs, refining the operations concept. You can see it in the hardware over my shoulder. This is a development lab where some of that co-designing of subsystems simultaneously is taking place. Um, um, Servicing of clients not designed with servicing in mind is a problem-rich environment.
Sure.
And which is good because problem-rich environments spurn creativity in innovative individuals, and I am lucky and proud to be surrounded by a group of extremely bright, creative, innovative individuals. So we provided the problem set, and they are co-developing subsystems to work together as a unified operational system behind me. And so we are marching towards through our formulation phase with a planned launch somewhere near the end of the decade.
And you have a target satellite in mind for the first mission, you're saying, is that correct?
We do. The right now and there's no plan to change it, but the planned client is Landsat 7, which is owned and operated by the USGS, a sister organization to NASA that is working with us on this mission. Wonderful organization and fabulous set of land imaging satellites that they operate for the U.S. and the world. Umpteen terabytes of data they've collected over 40 years of this thing we all live on together. Landsat 7 is dovetailing nicely with our planned launch date, such that it will be decommissioned as a science observatory, and then we will be given permission to approach it and then execute the steps that I've mentioned. This mission is not a Landsat 7 rescue mission. This mission is a technology demonstration mission to bring the suite of technologies that I've before mentioned to operational status using a real client, but it is not a Landsat 7 rescue mission. And then USGS will then take, well, they will always have possession of the satellite, but then they will retake control of it after we release it at the end of our mission. And then it will be up to USGS to decide how to use the additional fuel that it has taken on board.
Is the plan sort of to do one Restore L, or would you foresee having several of these for different orbits, or what's kind of the long game for that?
So there's two ways to answer the question. NASA's technology need is for a suite of technologies that enable servicing. Rendezvous and proximity operations, dexterous robotics, tools and tool drive systems to go with the dexterous robot, the avionics to allow those three aforementioned to actually work in space in the harsh radiation environment that it is. And then the fifth is fluid transfer, pumps, meters, valves, the ability to get fluid from one thing into another in space, which is kind of unique. So NASA has lots of future plans and ambitions to take advantage of these. So there will be many spawns of Restore technology across the agency in different instantiations. To build another Restore vehicle, not presently in NASA's plans. It's more the children of, or the derivations of. Another way to answer the question would be the commercial business case. NASA wants to develop the technology, get it to operational status, a la Restore, and then move on. Commercial businesses, that is their sweet spot. That is a sweet spot. There is a burgeoning commercial servicing field, and refueling is at the heart of it. Relocation, refueling is at the heart of it. As I mentioned earlier, 15 or so satellites per year retiring from geosynchronous orbit alone. It's a nice customer set.
Yeah.
If you're a car washing company, you go where there's a bunch of cars. You don't go out to the desert where there's one car per day. You go to a city where there's lots of cars, potential clients driving by. So the commercial business plan is to go to geosynchronous orbit to go where the clients are. And that would be geosynchronous orbit was probably the first, There is also a bunch of satellites in LEO polar orbit, which is where NetSat-7 presently is. Government and commercial both in LEO polar, just like GEO, but GEO is the sweet spot for the initial business case. So then it becomes a matter of, well, that size market, would that size market sustain a single servicer, one from multiple companies, multiple from multiple companies? Time will tell. Time will tell. I think an analogy I like to think about sometimes is the mobile phone, right? It was designed so that people could talk, be chained to a landline. Did initial instantiations of mobile phones, could they envision the Arab Spring being influenced by social media on mobile phones? Probably not. Probably not. But there's a tremendous influence on the Arab Spring and world events since then.
Yep.
So I can't predict all the ramifications that servicing is going to have on the satellite, global satellite industry. We can anticipate, I think, with some amount of clairvoyance, the first instantiations of the GEO relocation and refueling services. And beyond that, I can speculate, but then the fuzz gets a little bit greater because it's just going to be hard to anticipate with any clarity exactly how it will come to pass. But the fact is, for the first 60 years of spaceflight, globally, essentially we've been one and done. We globally launch a satellite, when it dies, it dies. One and done. When it runs out of juice, when its technology is obsolete, when the users no longer want that frequency, it's one and done.
Yep.
And now, that will be different. You can upgrade it, you can repair it, you can refuel it, you can relocate it, you can build something bigger than you can dream fitting in a rocket. And so, I think it is truly going to usher in Space 2.0. The era of one and done will be over, and the era of new opportunity will be upon us. And I'm just honored and proud to be part of that transition.